afternoon, Bruce McConnell here again with Locomotive Systems Training. We're still continuing on the FRA class. Again, this should be very enlightening for you. It's always, any information you can get is always good that you can apply on your job or just as general information. Anyway, FRA Locomotive Locomotive Inspection, Federal Railroad Administration, Part 1 continued. This is LSTV-019. Okay, let's go ahead and move on to the next one. All right, well, we left off, remember, this whole part of this presentation has been about from the running board below. Remember, the running board is where the operating crew and the mechanical department actually walks to get us around from one end to the other and one side to the other. Everything we've been talking about here so far is below the running board. That gets that extra scrutiny because, you know, you got things like the wheels, fuel tank, the trucks, the brake rigging, the couplers, the cutting levers, all that stuff, all vital to the safe operation of that locomotive and train. So I thought that'd be a good reason to cover this. All right, we left off in sand brackets. Now, why do we need sand? Why do we use sand? Well, you know, a locomotive, several hundred tons each, and you would think, well, no matter what the surface of the rail, whether it be ice, rain, whatever, grease, whatever we have on the rail, the weight of that locomotive would certainly overcome any of that and wouldn't cause the wheel to slip. Well, actually, that's not quite true. These locomotives actually are so powerful nowadays, they can actually slip. It's what they call wheel slip. So to prevent or reduce wheel slip action, they actually have a sanding system on board each locomotive that will actually deposit sand in front of the forward moving axle in each truck, or excuse me, forward moving axle, so we can apply sand to the rail, so we increase the adhesion and reduce the wheel slippage for that locomotive. All right, so sand bracket is an integral part of that system to help deliver that sand from the sandbox. There's a sandbox in the front of the locomotive in the nose compartment. There's also a sandbox in the rear of the locomotive back in the air compressor compartment. All right, so again, this is all part of the mechanism to help us get the sand from one location down to the wheel and the rail. Okay, so let's talk about the sand bracket. It says here the purpose of the sand bracket is to support the sand hose and the sand tip and properly align them to the center of the wheel and the rail where they meet. Now, one of the big problems we have, you know, this is a pretty rough location for this equipment to be at. Think about it. You know, you've got all the clang banging around of the wheel on the rail. It goes through switches, it goes through frogs, it goes through a lot of uneven territory where that wheel and journal box and the whole axle and everything here gets bounced around quite a bit. Well, all that shock wave, or what they call roadbed oscillations, is felt in this whole general area, okay, which includes also the sand bracket. So the sand bracket is mounted to what they call, remember from the last class, we call it a pedestal tie bar, or the slang term in the railroad industry called a binder. Well, the sand bracket is actually mounted below the pedestal tie bar or binder, and it all bolts up as one great big unit, okay? And it has to be rather stout because you can't see it here, but there's a sand hose that comes around, and you can catch it right here in the very edge of this picture where the sand hook comes in, and it actually, with the use of a hose clamp, will actually clamp the sand hose to the pipe or the sand bracket, okay? Now, the sand bracket is designed to deliver the sand or aim approximately at where the wheel and the rail meet, okay? And that's really a key point, which we'll talk about here in a minute as far as the defects go. So it's a rather robust piece of iron that's fixed, it doesn't move, and it's designed to get this rubber sand tip aligned to approximately where the wheel and the rail meet. All right, so let's go ahead and let's talk about this. These are the FRA rules that deal with that. Defects are loose or missing fasteners, bent or physically damaged bracket. Okay, something really simple can have a very major adverse effect on the operation of that locomotive to provide the tractive effort we need to get up these hills and mountains, if you will, and provide the maximum tractive effort we need. All right, let's go to the next one. Sand tip and sand hose. It says here the purpose of the sand tip, which is this area right here, to deliver sand to the surface where the wheel meets the rail. The sand tip is designed to spread the sand across the railhead for maximum sand delivery. The purpose of the sand hose is to move the sand from the sandbox down to the sand tip. Note, The sand tip delivers the sand at a flat horizontal flow. So while the sand is in the pipe or the hose, the sand is going through a round or circular shape. When the sand actually, remember it's air-driven sand, when the sand goes through this portion, which is round, of the sand bracket, and it enters the sand tip, it goes from a round shape into a beveled, almost flat shape. Because what we want to do is when that sand delivers to the rubber sand tip, we want it to be flat so we can get the maximum amount of sand between the wheel and the rail. Okay? So these are the FRA rules, and there's so many things we got to talk about here. We actually have to go over to the next slide. So let's go to the next slide. All right, again, sand tip and sand hose continued. Defects are, for the sand tip, loose or missing fasteners, sand hose, the hose clamps. They can be loose, twisted, stripped, worn, missing. Cracked, split, or worn sand tips. That's a pretty hostile environment where that rubber sand tip is at. It gets hit with dirt, debris, snow, ice, so it's a pretty rough area. So this sand tip is subject to a lot of hostile environment, if you will. Sand tip out of alignment. Now that happens quite a bit. These things get smacked around, they get loose, they get, from vibration, roadbed oscillations again. So these things have a tendency to shift a little bit. That's why I want to make sure all the sand bracket bolts are indeed tight, and we also want to make sure that the sand tip is properly aligned where the wheel and the rail meet. Because if the sand tip is adjusted down where the sand hits the rail, it'll have a tendency to blow off, and very little sand, if any, will be there available for the wheel. On the other hand, we want to make sure that the sand tip is not aimed up high at the wheel and hitting the wheel, because the same thing will apply. It'll disperse laterally on both sides of the wheel, and very little sand, if any, will get between the wheel and the rail, and hence we lost adhesion. All right, sand tip plug with wet sand. Well, wet sand doesn't flow, plain and simple. So a wet sand in and of itself is a defect because it can't flow. If the sand can't get delivered with air down to the sand tip, that's a federal defect. Okay? Sand tip less than 2.5 inches above the top of the rail. That's a huge one right there. So the closest thing we can have anything metallic to the top of the rail on any part of this locomotive, minimum clearance, not maximum, but the minimum clearance is 2.5 inches above the rail. Okay? The sand hose, right here. The sand hose, loose or missing hose clamp, ripped or torn rubber hose, a hole in the metal sand pipe or rubber hose. You got to remember, sand is an abrasive. So wherever you're looking at the sand hose, you need to inspect it carefully, because sand can actually, being an abrasive, can actually auger out or create a hole either in the rubber hose and or the actual metal pipe that the hose affixes to up near the top end of the by the top of the locomotive frame. Especially any pipe that has a bend in it, always look at that, because sometimes that sand will actually auger a hole into that area. Okay? Hole in the metal sandpipe, which is what I just said here, or rubber hose, and the sand hose making contact with any object. Now, again, the sand hose come up, you've got the stairwells, front and rear stairwells. As that truck as it pivots or rotates, going through turns and corners, that hose cannot rub on the stairwell. It can't rub on the windsheet knee brace. It can't rub on steps. It can't rub on anything. It just has to have total free movement without making contact. So if that rubber hose is making contact, that becomes an FRA defect. Quite a bit of information just on a little rubber tip and a bracket and a piece of round hose. Okay? All right, let's go to the next one. Brake cylinder. Okay? Brake cylinder, it says here, the purpose of the brake cylinder is to convert pneumatic force, air pressure, into a mechanical force, friction between the brake shoe and the wheel. This is the next to the last component in the air brake system that's designed to slow or stop the rotation of the wheel and or locomotive and or train. Okay? There's the FRA rules that deal with it. Defects, loose or missing fasteners. Sometimes these bolts, there's 4 bolts that affix this to the truck frame. Sometimes them bolts can get loose and actually come out missing. Remember, there's a lot of vibration, a lot of banging, clanging around going on there. Okay? Physical damage. Usually the physical damage we incur here is a result of what they call a sideswipe, where a locomotive will impede with a boxcar, another locomotive, or a structure, or something goes into that, okay? So, again, you're looking for any physical damage. If it's not normal, that's probably going to be a defect. Again, these bolts here that hold this end cap of that brake cylinder on, they can get loose, so on and so forth. Brake cylinder vent plugged. A vent. On the very bottom, right there, is a little bitty, it's about the size of a silver dollar. And what it is, it's a vent that's designed to do two things. It's allowed to let air in when the piston retracts back from a fully applied position back, and it also lets the air out as the piston indeed comes forward. What'll happen sometimes is that these vents will get packed with dirt, grease, oil, mud, whatever, and it will not let the air either out or in. That would become a defect. Air leaks, pipe connections, bolted flange fitting, or piston sleeve. Remember, when I have this brake applied, if I apply, say, the independent brake, and on a lot of locomotives, I can get up to 72 pounds of independent brake cylinder pressure. If I got 72 pounds, if I get a leak either coming into this pipe or coming into this connection here or air leaking into here, probably a pretty good chance I'm going to hear that. But any air leaks definitely becomes an FRA reportable, because remember, this component, like every other air brake component, is designed to have the maximum amount of air delivered to that to work effectively and properly. If I have air leaks in here, I'm not getting my full effective braking, and that becomes an FRA reportable. Worn clevis pin. We've talked about this way back. I can't even tell you what video it was, but we talked about foundation brake rigging, and which we're going to talk about here in a little bit as well, where any pin or link or whatever cannot be worn more than 30% of its cross-sectional area. And if you think about it, you know, that's a lot of wear. Okay, so if I have one clevis pin here, or a pivot pin here, or a brake head pin down below, or a pin here for the brake rigging, they're only allowed so much maximum wear before they're considered defective, and they have to be changed out. All right, I think we beat that up pretty good, so let's go to the next one. Now, in the last video, we talked about the swing hanger, but again, I just want to impress upon you the importance of how this thing operates. You got to remember, each truck supports half the weight of that locomotive. Okay? The swing hanger has a pivoting action in two places. One place is these two pivot pins at the top, where my shoulders would be, and down below they have an upper and lower bearing block, and that's the bottom. Remember, as that locomotive goes around a curve or a turn, that has a natural tendency, centrifugal force, to take that locomotive and to make it swerve left and right. Okay? Well, working with the side bearings that are on the truck in here, like we mentioned last week, it allows a pivoting action, but it also limits how much that can turn. Now, I don't remember if I mentioned it last week, but I think I did, but at the sake of being rude, I'm going to go ahead and throw this back in here. We want to look for pin and bearing wear, and I've never seen a pin worn. Not to say that it can't happen, but I've never seen it. But when this bushing here wears down, and if I have more than an 1/8 inch clearance or more, then I would change that out. And again, that's not an FRA rule, that's a manufacturer's recommendation. Now, one thing you always want to pay close attention to is right here in these corners, they will crack. And when they crack and break right now. And what will happen is, the reason that happens is this upper and lower bearing block that sits underneath this spring plank, when they're being replaced, if that upper and lower bearing block makes any contact with the radius of this swing hanger right there and right there, it will create a stress point, and you will crack that. You literally build in a failure and you don't even know it. So always look in this area here for any starting cracks or a crack that actually is broken through. Okay. All right. So which is what we talked about. So let's talk about the defects. Loose or missing fasteners. And again, we beat that up a lot, but it's true. Cracked or broken swing hanger, which we just mentioned. Worn or broken pivot pins. Again, almost 40 years of railroad, and I have never seen one of these pins break. Not to say that it's not possible, but I've never seen that. But you still want to inspect it for that. And again, here we have, notice the pivot pin to bushing clearance greater than 1/8 of an inch. Again, not a federal violation. Cracked or chunked out bushing, change it out. Missing pivot pin retainer. Okay, remember that retainer is vital to keep these pins in place. Now remember, I mean, we mentioned it before, the pivot pin retainer will be loose even though the bolts are tight, because the retainer on the ends are two open slots. Okay, So if you grab a hold of that retainer in the middle, it will be loose. It'll go clink, 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 but it should not be able to move. Well, it'll move longitudinally front and back, but it cannot be pulled out between that bolt there and that bolt there. Upper and lower bearing blocks run past the 1/8 inch wear limit. Again, 1/8 inch wear limit. Note, not a federal violation. Cracks in the rubber spring deeper than 1/4 inch and longer than 1 inch. Now, there's two different types of springs that we can have on these two axle trucks. One is what they call a metal leaf spring, okay, where they have like a leaf spring on a pickup truck, if you will, or a lot of cars have leaf springs, and where they'll have a whole stack of them, what they call a spring nest. Okay, it'll have upper and lower, and then it operates very similar to what my hand is doing right there. Okay, the other type of spring we have is a rubber laminated sandwich spring. It's great, big, massive lamination between steel and rubber. Now, and again, if I start developing cracks in that rubber, 1/4 inch deep or deeper, or they're longer than 1 inch, then that becomes a defect and it needs to be replaced. And we mentioned it the other day, less than 3 inch clearance between the bottom of the spring clank and top of the safety strap. Again, that's not FRA. That is a company specification or builder and specification. So what we need to make sure of is where that spring clank moves back and forth between the opening of this safety strap. We do not want to make any contact between the safety strap and the spring clank. Okay? AMD recommends minimum of 3/8 clearance. Okay? Whew, a lot of information to talk about here today. Let's go to the next one. Brake rigging. All right. You know, the locomotive has air braking, whether it be electronic or pneumatic. Doesn't matter. The purpose of every air braking system on every locomotive out there is to slow or stop the locomotive and or train. And the way we actually do that, the final part of this whole system, is what they call the brake rigging. Brake rigging can start right out here by this big lever out here that connects to the piston, the brake cylinder piston. Piston comes out, that lever moves, it pivots, then it goes over here to a big clevis inside the top deck, or the top upper area of the truck frame. Then it goes down to what they call a brake beam or brake lever. Then attached to that brake lever is a brake head, and which the brake head contacts and holds in the brake shoe. And then at the bottom, the pivot point there in the bottom, you'll have what they call a brake slack adjuster. The brake slack adjuster is designed to take up wear between the brake shoe and the wheel. Now, of the two components, the one that's designed as a replaceable wear unit, obviously, is the brake shoe, because brake shoes are a lot cheaper to replace than this very expensive wheels. Okay? So as the shoe wears down, the piston travel increases, and there's federal limits on how long that piston travel can be before it has to be adjusted. But all the information I talked about, the levers, the beams, the brake heads, the slack adjusters, all those is called brake rigging. And again, let's take a look at it. The purpose of the brake rigging is to convert a pneumatic force, air, into a mechanical braking force. Brake rigging consists of rods, levers, beams, brake heads, brake shoes, brake slack adjusters, lateral restraint pads, and brake guide bars. Well, let's talk about what a lateral restraint pad is. Well, you may or may not know this, but on freight locomotives, where the tread of the wheel is, the tread is the area that makes contact with the rail. Well, on a locomotive, a freight locomotive especially, that tread is not flat, it's actually tapered. Okay? And what will happen is every time you apply the brake shoe to the wheel, and if the taper is this way, the brake shoe will have a tendency to move outward towards the outside portion of the wheel. Okay? Well, to prevent that, we have what they call lateral restraint pads and also brake guide bars to keep that brake shoe approximately center line with the tread of the wheel. A lot of things to look at, a lot of things to make sure that are correct when we inspect this locomotive. All right, so let's talk about the defects. Loose or missing fasteners, and believe me, there's plenty of fasteners here to look at. Bent, damaged, or stuck slack adjusters. Okay? The FRA has come out with new definitions on binding and restrictions, things like that. The brake rigging must be able to move freely, but still do its job correctly. Okay? Brake rigging out of alignment. Again, as these pins and bushings, lateral restraint pads, and brake guide bars get loose or wear, that'll have a tendency for the brake shoe to migrate towards the front edge or the outer edge of that wheel. We don't want that to happen. Stuck, frozen, or damaged brake slack adjusters. Again, the cool part is nowadays most, and I'm sure there's still some other, but most of the slack adjusters, what they call a pin type slack adjuster, where you have a pin where this portion here will slide into this portion here, and you remove this pin, you adjust, you either take the slack out, or you pull it in to change out the brake shoes, and you move it out, and then you put the pin back in there. And they're really easy, very effective, very low maintenance item compared to the old screw type slack adjusters that used to be on these. And if you worked on the screw type slack adjusters, you know what I'm talking about. But even this pin type can get frozen or damaged. Remember, that is a very hostile environment. Right up, probably 4 to 6 inches right above the top of the rail, dirt, debris, stuff that you hit, clang bang, rain, snow, abrasiveness. It's a really pretty hostile environment. So we can, from time to time, get a brake slack adjuster to freeze up and won't move. Defective brake head, which I mentioned earlier. Bushings worn out, pin worn out, brake shoe making contact with the wheel at the top of the brake shoe. So, what's the FRA definition of a release brake? Well, a lot of people think, well, it has to do with the brake cylinder piston. Well, sort of, kind of, but what they actually look for, then when that brake is fully released, we're hoping that the piston is all the way retracted against this collar, against that housing. But more importantly, they want to make sure that that brake shoe is not making any contact with that wheel whatsoever. That's what they're looking for. All right, so let's move on. Oh, well, here we are. We're already at the end. Anyway, so some really cool stuff. Again, all of this is vitally important to make sure that the locomotive is compliant so we can operate safely and protect the public and our crew. Again, I encourage you to go to this website, www.fra.dot.gov. Once again, www.fra.dot.gov. And also, we're getting more and more cool stuff into our program. Now, again, I want you to go visit our website, lst-ca.com. Once again, lst-ca.com. Call us, write us, tell me what you think of the program, tell me what you'd like to see in the future, and we'll go from there. All right, this being the holiday season, I want to stop and thank everybody for their participation, and I want to wish everybody a happy holiday. And if the holiday's already come and gone, hope you had a great holiday, and we'll start the new year and we'll keep going. Thank you and have a safe day.